Lesson 6-1C, Properties of Exponents, Extra Examples. So here are the properties of exponents from last time. As a review, we have the addition of exponents, subtraction, the distribution of exponents between product and quotient, and then the multiplication of exponents. We also have the exponents to the 0 power, so anything to the 0 power is equal to 1, and here is the example we looked at last time. And last, we have exponents that are negative. Remember that if we have a exponent that is negative in the numerator, we can relocate that to the denominator. And if it's a negative exponent in the denominator, we can relocate that to the numerator. And the example we worked on last time. All right, so here we're going to take a look at 4 different examples involving a mixture of different rules. So example number 1 is x to the negative 3 times y to the negative 2 over y to the negative 1. What I like to do first is to make all of my exponents positive to begin with. Okay. So what I want to do is grab x to the negative 3, bring that down, grab y to the negative 2, bring that down, and then take y to the negative 1 and bring that up. And I'm going to rewrite my problem with all positive exponents. So I have x, I have y to the first divided by x to the 3, y to the second. Now that I have all positive exponents, now I can apply the properties of exponents. Here we have y to the first over y to the second. So I'm going to have to subtract the exponents. So if I have y to the 1 minus 2 divided by x to the 3. Carrying out this operation of y to the 1 minus 2 means that I'll have a negative exponent in the numerator. So y to the negative 1 over x to the third. And then to finish this problem, I need to turn this y to the negative back into a positive exponent. So I'm going to take this and bring it back down. So my answer is going to be, at the very end, 1 divided by x to the third, y to the first, or just y. Here's the next example. We have w to the 0 times 4w squared times w to the fourth, and that all of that is being raised to the third power. All right, using the properties of the distribution of product, we're going to distribute the 3 to all possible exponents here. Now, did I get all of these? I did not get all of them. 4 also has an exponent of 1, so don't forget your number terms as well. All right, so rewriting this, I have w to the 0 power times 3 times 4 to the 1 times 3, w to the 2 times 3, and w to the 4 times 3. All right, all these operations are happening. They're all multiplication. All right, let's take care of this one first. W to the 0 times 3 is just w to the 0. 4 to the 1 times 3 is 4 to the third power. W to the 2 times 3 is w to the sixth power. And w to the 4 times 3 is w to the 12th power. All right, before I go on, I have w to the 0 power. And if you remember, anything to the 0 power is equal to 1. So we can actually rewrite this first one as 1. Now let's expand 4 out. So we're going to have 4 times 4 times 4. And then last, we're going to end up adding the exponents here for the w. So because we're multiplying, we have w to the 6. When we multiply, we add the exponents. So 6 plus 12. All right, so 1 times 4 is 4. 4 times 4 is 16. And 16 times 4 is 64. And w to the 6 plus 12 is going to end up being w to the 18. So this is my final answer. All right, here is the next example. We have 2y to the 4th power divided by 4y, all being raised to the 2nd power. Before I begin, let's add exponents to all of these, exponents of 1. Now we can distribute this to all the exponents. All right, rewriting this, we have 2 to the 1 times 2, y to the 4 times 2, divided by 4 to the 1 times 2, and y to the 1 times 2. Multiplying all the exponents, we have 2 squared, y to the 8th power, 4 squared, and y to the 2nd power. All right, multiplying out the numbers, 2 squared is the same as 4, y to the 8th stays, and then 4 squared is the same as 16. Now, because we are subtracting or dividing the variables here for the exponents, we're going to end up subtracting. So here I can subtract 2 from the exponents. All right, and then simplifying this in one more step, I can divide the numbers. That's the same as 1 over 4. And the variables are y to the 8 minus 2, which is y to the 6th power. And if I wanted to, I don't have to keep that 1. So my final answer is y to the 6th divided by 4. We have 5x cubed, y to the negative 5, all being raised to the 0 power. And we know that anything raised to the 0 power is going to end up equaling 1. All right, let's do a little bit more work to show why this is the case. So if we add an exponent here and then distribute the 0 to all these exponents, we have 5 to the 1 times 0, x to the 3 times 0, and y to the negative 5 times 0. 5 to the 1 times 0 is simply 5 to the 0. Same with x to the 3 times 0, x to the 0, and y to the negative 5 times 0. And we know that independently, all of these are equal to 1. So 5 to the 0 power is 1, x to the 0 power is 1 as well, and y to the 0 power is 1. If I multiply all of these out, 1 times 1 times 1, I end up with my final answer of 1. So that's why all of these and anything close raised to the 0 power is going to end up being 1.